different types of engineering. Now this pales for what Sue had, like she had 45 different things a nurse could go into. And these are the ones that the present College of Engineering has, and we're talking now about mechanical and aerospace engineering down here at the bottom. This is their salary in those different areas. And you can see their mean salaries in $100,000, and nuclear is kind of at the top with aerospace. So this is mechanical and aerospace engineering. When we started, we had slide rules. These are samples of a slide rule. These are antiques, so treat them with care. But when we started, that's our calculator.
Oh my gosh.
No decimals and no.
And if you look at, I need to try to give you that.
Well, he moves this little thing.
You need one?
That's all right.
He's just brilliant with
If you
this.
look right here, you see the one?
Can you see a pointer on this? Fred?
I don't know.
If you put that at a 1 and you go to the 2, so this is at a 2, you go to that 2, that gives you 4. So you can multiply and divide, to divide you do the opposite. You have to go backwards.
Oh.
But in those days, this was your calculator. So the critical part about using a slide rule is you'd have to keep up with your units, because it has no units. And also, it doesn't keep up with the location of your decimal point. So you have to keep up with that. Okay? Right now, we're going to take you to a class in mechanical and aerospace engineering. In one of our classes in my senior year, the professor did not show up. So you got 30 boys in there deciding what we're going to do at this class. And we're in this 10-story building, and the windows open. So we decided to have a design class. And the design class was building a paper airplane. You have 1 minute to take your piece of paper and fold it to make a paper airplane. 1 minute.
Been a long time since I've done this.
Are they going to have their brother? Save it.
I don't look good, but I'm not sure why.
So it's Larry and Parker. Larry and Parker going to compete. Brad speed-wise and stay.
Brad, you got yours ready?
You want us to open windows?
Haven't made one.
Brad, you still have 30 seconds.
Well, I think I like mine better if you got 30.
Mine's gonna be so boring compared to this stuff you're doing.
As long as it flies, Larry.
That's
We used to make these all the time, but it's been a while.
okay. Stop flying. Okay, you now have participated in the mechanical and aerospace design classroom. Congratulations. You are now only 4 years short of your degree because you've only attended one class. Then after we graduated with Alcoa, if you ever noticed the street names in the city of Alcoa, they all relate to electrical, aluminum, some sort of technology. So as they were naming the streets, that's how they used those for
Didn't know that.
a significant amount of the street names. When I started, it started on a drawing board. There was no CAD systems back then. You had a drawing board, you had a pencil, an eraser, and a ruler, and triangles. And if you wanted to put something in the middle of your design, you had to erase the whole other side of it and put it in. You couldn't click and drag it over. And then I was assigned to go into the West Plant area. That area now is where Costco's going and where Texas Roadhouse. That was the West Plant area. And we made toothpaste tube slugs, guardrails, foil, aluminum tube, roofing sheet, and military casings. Held it, give everybody a sheet of foil. So what do you notice about the foil? Is there
Shiny
anything?
on one side and dull on the other.
Now, do you know why that is?
I have no idea.
Okay. On the right side, you'll see two circles. Those are unlines with a roll of aluminum. As you go to the center, that's the rolling mill. You have backup rolls, work rolls, backup rolls. The backup rolls keep the work rolls from bending. And on this side, you have two rewinds. When you're rolling aluminum, you can only roll it so thin. So they developed a process to where you could put two sheets in the mill to make thinner pieces of foil. The bright side of your aluminum is against the work rolls. The dull side is where the two sheets touch each other. That's why, and there's no difference in the performance of the foil. It's just that the work rolls are mirror bright, and when they touch each other, they come out with the dull. So now you've learned something about aluminum foil. Then, as a part of this, I was sent to Edgewater, New Jersey, which is across the Hudson River from New York City. And we had a multi-storied building. It had blanking presses and rolling mills. And while this was going on, the Coca-Cola came over and saw this 8-story building and thought, we'd like to put a Coca-Cola sign up there. So Alcoa got that, well, maybe we ought to put an Alcoa sign up there. So they did that. Now the plant, when it was built, they could not buy the land in the center where it was a cemetery. So they built this 8-story building around the cemetery. So when they have a funeral and want to bury somebody, you shut the plant down because the plant got hum, and it's got boom, boom. You could walk in the building, and the blanking presses made an obvious sound and a vibration. So they shut the plant down, they have the cemetery, have the funeral, and then when it's over, they come out and we lock the gates back and start the plant back up. My job was to bring down some blanking presses. And these blanking presses had blank out pieces of aluminum that are probably 1 to 2 inches thick and probably 6 to 8 inches diameter. And that blank of aluminum then goes to another process, and it made ballistic shell castings for the Vietnam War. So part of my deferment was I was working on something directly related to the military, and that's how I got a deferment from the Vietnam War. Another thing in these blanking presses was a toothpaste tube slug. If you can see that, it's a slug about the size of $half, and it has a taper to it.
Oh, yeah.
So these slugs would roll down this inspection conveyor, and if you looked here, it was a blur. But you could follow one, it was that quick. It measured the height, the ID, and the OD. And if it's out of spec, there was a jet of air would, and it would kick that particular slug in the scrap. And then those slugs were later on used in those days for toothpaste tubes. Now, speaking of toothpaste tubes, do you know where a toothpaste was invented, anybody know that? Is Alabama. If it was, had been anyplace else, they would have called it teeth.
That's surprising, because Alabama's toothless.
You got it. We also made guardrail. Back then we had multiple products. Today they probably have two. That's can, sheet, and auto. Another product we made was roofing sheet, corrugated roofing sheet, and that was my area. So we have a plant in West Africa, in Guinea. And in Guinea, you can see Conakry and Bouquet. Conakry is where the plant was, and we gave them a plant. And this plant made some of the samples of things that we made there. And now this is 1980, and back then that was what they needed. And my job was the corrugated roofing sheet. That was my area, and they had a roll former that made these, and the cutoff shear to cut off each piece. It accelerates to the speed of the aluminum as it's being rolled. It cuts it off, it opens back up, it backs up to the initial location, and gets ready to cut off again. And it comes out, and it shears it, and the sheet, the die on the cutoff shear has to be identical to the corrugated piece, otherwise it flattened out. My job was to go over there. They were having problems with their shear. My job was to go over there and repair the shear and get it running properly, but do not increase productivity, because we were giving them 3 million pounds of aluminum a year to make these variety of products. And if I increased the productivity, they would want more free aluminum. So my job was do not increase the productivity. Now I stayed in a guest house down in Conakry. If you take a vehicle from Conakry up to Bouquet, it's about a 3-hour drive over bad roads. So the manager there decided he's going to get an ocean-going boat. And he would then go from Conakry up to Bouquet in about 45 minutes. So he got the boat, got ready. He couldn't get a permit because the president of the country wanted access to use the boat. So that when I was there, they were in a kerfuffle to do that. So, but when I was there, I always had a guard, a security person. A security person in Conakry is a local. You have to have, he doesn't have a gun, or is not trained, doesn't have a uniform. It's just a local. Now, if I'm out by myself in the plant, I was the only white person. I was never in fear of anything in the plant. But I never went outside the guest house or out in the city. That was not okay. And the guard that was with me, he brought his girlfriend over at night, and they would sleep on in the carport, on the couch, in a carport. But as long as there was a local there, people could see in and everything was okay. Now the females walked down the street with something on their head, and that they could balance that. If sometimes they would, they wore like a sheet. And sometimes if they needed to straighten it out, they'd take it off and flush it. And they didn't have clothes on from waist down. But waist up, didn't have any. And in front of this house, there was an intersection. And one day I went out there, and the ladies had blocked off the intersection because they wanted to dry some of their food. So the cars had to drive around the intersection on the dirt and grass, while the ladies they were drying their food for the day. So that was then we went to Texas. Let me go back here. There's a God thing. When I flew into Conakry, they took your passport. And they also wanted you to change all your aluminum, all of your US dollars to their currency. And their currency was worthless. So you have to hide your US dollars. They're not telling you, you got it. And the plane comes in maybe every other day. So as a part of this, Hilda and I were going to meet in Madrid, Spain. And don't have cell phones. But we just knew that we were supposed to meet in the airport. So I was going to the airport, they have my passport. The guy didn't show up with my passport. So I get to tell the driver, we got to go back. So we go back to the plant, said, I don't have my passport. He said, I forgot it. So now he goes back to the government office, gets my passport. We rush back to the airport, barely make the plane. So we're now going to meet in Madrid. Hilda, tell the story of Madrid.
Well, Hilda hadn't been out of Wallen, and I get on a plane and I land in Portugal, and then I go to Madrid. And there was a couple, and I call them my guardian angels. And they stood in the background, but they just kind of watched after me. They showed me which gate to go to, because I couldn't read any of the language. And we were in Madrid, and they had this big glass wall, customs and not customs. So they kind of sat over behind me. And when I saw Larry, I just ran and we got together. And I've always regretted not going and thanking them for being I left and I've never thanked them, and that's always been a sad thing for me. I should have, because
I
they
can
really,
imagine if they saw you hug Larry, that was.
yeah, probably.
Okay. Next we went to Texas, a place called Rockdale, Texas. And it's between Austin, and Austin is here, College Station's over here, and it's right in the middle. It's called Rockdale, Texas. Our job was, in those days, this was 1980, the fuel for space rockets was aluminum powder. And aluminum powder looks similar to salt or sugar. Now don't shake it too hard, we don't want you to explode.
So this is aluminum powder.
It looks like aluminum
Looks-
powder.
And that's what those rockets use for
That was the
fuel.
fuel,
Salt.
and the plant blew up.
Yeah.
So the plant was a tower, a 10-story tower, open. It blew up, and Hilda and I were sent down to rebuild it. So it's a 9-month assignment. Now, the space program now has no fuel in the pipeline. So you can imagine the pressure on us to get that plant back up and running. 6-7 days a week, all the hours that the engineers would work. And this tower was open, no walls, just steel and equipment. And if a person, people are not in the plant while it's operating, you keep everybody out in case something happens. But say you have an operator or a mechanic or electrician at the top of this 10-story tower, and he doesn't want to walk down all the steps. There was a slide, a corkscrew slide, 10 stories. So you step in this slide and you slide down, and it kicked you out at the bottom. This is a typical pot that makes aluminum. You got an anode and you got a cathode. And the typical pot room looks like this. This is one room. A pot line has 2 rooms. Power goes down, it comes back. Those rooms today in Rockdale are full of Bitcoin computers. The people who have the Bitcoin computers see that the electrical infrastructure, which is tremendous to operate a smelter, is enough to operate their computers. So the sides are open, and you just look down through there and you see hundreds of computers. Then we moved to Pennsylvania, and there I was the engineering manager, and I had engineering, maintenance, buildings and grounds, machine shop, security, and had about 160 employees there. And when you're in charge of a machine shop, there's all kinds of things that are interesting that you can make in a machine shop. All of the employees were salaried. It is a significant difference when you have a plant of steel worker union employees and you have all salaried employees. Because all of the mechanics and electricians, they function just like an engineer would at a plant. It's a different atmosphere. My operating budget there was about $20 million a year. Plus, a capital budget would be between 5 and 30 million, depending on what we were doing. So then we moved to Knoxville Primary Metals, and I was the project manager there for inner anode. Now let's go back. This anode, the three black things on top, that's the anode. Today they last about a month. Our job on this project was to make those last 2 years. And to do that, the effluent that comes with the gases that come off is like O2. So it makes a significant difference in the production of aluminum. You could put a smelter using the inner anode anywhere because it had no bad gases coming off of it. So that's where I had the 160 employees, and they were all salaried. And then that inner anode, I wrote the authorizations for the facilities. I was not in charge of the research. And the fourth authorization I wrote, you got one, now the next guy had a higher approval level, so I just kept writing to whatever approval level the next guy had. And the last one exceeded $100 million. So in an engineering career, if you want to be an engineer, you can go into design, large and small mechanisms, solve problems. You can go into R&D. Most of the people in R&D have a PhD. Then you can pursue other paths. Matter of fact, there's a doctor here in town that worked for Alcoa, and he didn't like working in the steelworkers, so he went back and got a doctorate degree. You can be a patent attorney. Most patent attorneys have some sort of engineering degree. And you can be an entrepreneur. There's some people in this room that are entrepreneurs, and they're extremely wealthy.
And ain't me.
I want to spend just a second on safety. I've been through 2 fatalities. When you hear people being crushed in a ditch, we know how to keep that from happening. And there's a process called lock, tag, and try. You lock out a piece of equipment that has energy, mechanical or electrical. You put your tag on it, it says, you're the person. You're the only person that can take that off. And you put a lock on it. And you have the only key to it. And if you do that, and you test the equipment, that's where the try comes in. You test it. If you have no energy left, mechanical or electrical, then you can safely work on that. If you don't do this, you could get in trouble. Credits. I had a lot of help in this thing. Maddie Burns is the one that gave me the UT information. Jackie Taylor, she is the person that at the library will help you. You can sign up for classes and she'll teach you computer stuff. Brad Brown, he's my tech guy. I had some things I couldn't do. And Brad took my computer, and after 41 steps, he got some things I had on my laptop over in this presentation. And if it comes down to it, if you want young, female, nice looking, you go to Jackie. If you want somebody that knows what they're doing, you go to Brad. Because he was the one that, actually, he was more knowledgeable about what I needed than Jackie, who teaches this stuff. And Hilda, we had competition to be my partner, and the ladies on TV,
Dana White.
Dana White.
Dana
Dana
White.
White, she didn't make the grade. And the Price is Right, those females, they were tied up in Bob Barker, so it came down to Hilda, and then Larry Campbell. Thank you, thank you.
Take me a minute to get set up here.
How did you do on this time?
Larry, what did you eat in Africa? You said those ladies were drying their food out on the road?
For breakfast, I had eggs and bacon. Lunch, I had a snack at the plant.
That was American food?
No, it was like a sandwich or something like that. And in the evening meal, I'd go into the guest house and go to the kitchen, and they'd open up the refrigerator, and I'd point to something. And then they had two cooks, and they would fix your meal. But you never drink the water.
Don't drink the water.
You always had bottled water. So I ate
The
okay.
food was okay?
Food was okay.
And the workers in the plant there wore flip-flops.
They wore, was that because they had no shoes? Or that's just-
They were shorts, t-shirts, and flip-flops.
And here they
No eye
wear
protection.
safety-toed shoes.
I was gonna say, here it'd be illegal, OSHA would be. Well, that's interesting, when you go to different countries, cultures, and you were scared of flying because you,
Well, yes, it was a big.
If I can be as entertaining as Larry, I mean, I'm not known for being entertaining. Well, I'm wearing this shirt because it says, never underestimate an old man with a degree in chemical engineering.
Amen, brother, amen.
I've
So,
never seen a shirt like that.
well, chemical engineering is a diverse field. You have to have physics, you have to have chemistry, math. I took a lot of math, and it's they're basically broken down into like process engineers and scale-up engineers. So the chemist in the lab will develop some chemical that's useful for making, say, polymers or paints or any of those kind of things. And then each one of those inventions has its own characteristics. It might generate a lot of heat. It might be difficult to stir in the pigment. And the process engineer would work on scaling it up from a little pot to a giant cauldron. They work in all kinds of scales. I wanted to do an R&D, and I had a lot of interviews with companies. And hard to believe this, but when I graduated from Purdue with my bachelor's in chemical engineering, I weighed 127 pounds. So I interviewed with the oil companies, and they said, I can't see you being a supervisor for any of these big monster guys that are working in a plant. So I interviewed Campbell Soup, and they didn't want me either. So I'd already made in my mind that that I wanted to go into R&D. So right away when I went to Purdue, I looked at the curriculum and I said the hardest course is the engineering course. It's got lots of math and lots of problem solving. We took the same courses as the chemists, but the chemical engineering group was. We also had experience in. I'll just go through this stuff and I'll tell you some of the experiences. They have a wide range of. It's mostly process design and optimization. If you get into R&D, you have to have almost an advanced degree in chemical engineering if you want to go into process development, R&D, developing new products. And newer businesses, so of course the safety and environmental compliance has become a major issue in the last, since I left Purdue. And they collaborate a lot with other engineers. As a chemical engineer, I took 1 semester of metallurgy, 1 semester of electrical engineering, 1 semester of mechanical engineering, so that we would have the vocabulary so that we could work with other engineers. So, where do they work? What do they do? Well, the biggest one is oil and gas. And there's a Permian Basin in Texas. It's got almost 1,000 years worth of oil and natural gas. And that's where most of these engineers work, in Texas. Pharmaceutical in New Jersey and Connecticut and those areas. Food processing, that would be the Campbell Soup. Even they changed their name to Campbell Technologies. It's not Campbell Soup anymore. Renewable energy, environmental protection is a big opportunity for engineers these days. They may work in a laboratory or a manufacturing plant or in an R&D facility or in offices where the process design is going on. So to become a chemical engineer, a degree in chemical engineering or related field is typically required. But my experience is someone who gets out of high school that's got a good head, good brain, if he works with engineers in 2 or 3 years, he's just as good as an engineer. At least a process, maybe not the design part, but in the laboratory. So if you wanted to go into R&D, you can see you really need a master's or a PhD. At Purdue, I had the option to test out of the master's degree. They give you a test on all the different forms of chemistry that you are not majoring in. And if you pass that test, you can go directly for the PhD. So I don't have a master's degree, I didn't master much. Focusing on waste management, pollution control, as I said, this has become more recently a big area for opportunities for chemical engineers. What do they do? Big one was a refinery, petroleum refineries. I was too skinny to work there. Plastics, food, beverages, cosmetics. And they focus on converting raw materials into valuable products and designing the plants, improving safety, and make the process more efficient. The skills, you have to have a strong understanding and love for chemistry and math. And you have to have analytical, where the chemical engineering came in for me is that it was all about problem solving. And so that's a special art and special mental ability or desire. And of course, again, environmental awareness. Everybody's worrying about the environment, and for a chemical engineer today, 121,000 in 2024 was the starting salary. I started with the highest offer in my class at Purdue at $14,000 a year. And that would seem to be enough to get it by. So chemical engineering is really a vital field. I mean, there's so many areas to work in: medicine and food and environment. I'm glad I took it because when you're in business, I never had any business training, but being an engineer helps get your mind organized for the flow of how things should go. Now, why did I become a chemical engineer? My mother had 4 brothers and 3 sisters. And my uncles, they really sort of raised me. My dad was in the Navy and during World War II, and they raised me. And one of the youngest of my uncles was like 10 years older than me. But he got me a chemistry set when I was 6 or 7. And that got me on the road. In high school, I was growing crystals everywhere. My bedroom was full of different crystals growing. I actually, Bell Laboratories was sort of the area for technology in those days. And there was a guy there developing what's called a piezoelectric crystal. A piezoelectric crystal, if you squeeze it, it will build up a charge. So an accelerometer in an airplane, as the plane increases the acceleration, that little crystal gets squeezes and prints out or displays a number for the acceleration. And my pet peeve is when someone on weather guy on TV says that the car was going at a high rate of speed. A rate, that would be acceleration, but they just incorrectly call it the rate of speed. I want to correct them all. So I stayed at Purdue for my PhD in chemistry, but this is chemical engineering, so let's go ahead. Most of my professional life has been involved in catalysis. And one of the first materials I used in catalysis was we had to put a coating on, and it was Alcoa's aluminum powder was the first coating for automobile catalysts. I don't know if you knew that or not, but you know Bernie Sanders? Did you know him?
Oh, yeah.
Well, Bernie was somehow involved in that production of powders. So these catalysts are used in the synthesis of pharmaceuticals, the conversion of petroleum to fuels, and the protection of the environment. That's been my experience. For environmental applications, the laboratory reactor is used to screen materials. So there are three variables that are important if you're looking at a catalyst. One is the catalyst activity at different temperatures, and the other one, space velocity is described as a kind of a speed. You take the unit volume of catalyst that you're using, divide by the speed, or the velocity, not velocity, the rate. And that will give you a number which every catalyst can be compared to. It's called space velocity. And so it's the volume of the catalyst divided by the flow rate. And then in a typical automobile, that number would be 100,000. So it means that the catalyst is processing its own volume 100,000 times an hour. And then finally, the thermal stability, because with an automobile, the temperatures can go up to 1,000, can go down to 400. So what I'd like to do is take you through a little lesson in catalysis. These are the steps in catalysis, okay? You know the automobile catalyst is a honeycomb. It's got the little channels in it. So if you just think about that, first, the material enters the catalyst, and these molecules are itty-bitty little things, so they're jumping around all over the place, and that's called that's bulk diffusion. And that first step you have to do is get the molecule on the catalyst. So the second one, the catalyst coating is porous. I'll have a picture to show you that. So then the molecule has to go into the catalyst, the coating, to reach the platinum. And then finally, the platinum distorts the molecule and makes it more reactive. And then once it's changed, it has to diffuse out of the wash coat and out into the channel so it can get out. So it'll all become clear. This is an example. What I'm looking at here is one of those channels. And it has a coating on the inside. And this gray material represents the coating. And the little yellow balls are platinum. So it comes in, you can see the raw material is blue. It rattles in those little channels. And then it hits a platinum and it gets converted. And then it makes its way out of the catalyst. I just show one of these, but there might be several, like a 10 to the 26th of those molecules in that channel. And here's an example where some molecules get through without touching any catalyst. That's a bad design if that happens. And some do get converted. And this one is showing you the pore diffusion. You see, the molecule can get in one of these holes and it just rattles around in there until it can find the platinum. until it collides with the platinum. It doesn't search for the platinum, it just hits it. And then it comes out and then makes it all the way through without any conversion. That's a very small number. And this one actually shows the molecule. What I didn't show is here is hydrogen. And the hydrogen reacts with, at the catalyst point, reacts with that molecule. And you can see the double bond is gone. It's been converted to this compound. Getting all this?
What goes in and what comes out?
What goes in is exhaust from your truck, and what comes out is a much cleaner, non-toxic material that's basically water and carbon dioxide.
So is that like a catalytic converter
Yeah,
in a car or boat?
that's what I'm showing. And if you look at your catalytic converter, it typically will have 400 little holes in a square inch. And each one of those little holes is a channel like this. And it's got coating in it, and it's got platinum on the coating. And this is just to show you, exaggerate, this is more like what's really the case, is that the molecule, the black one, that's the reactant coming out of your engine. And it would come down and shake around in there until it sees platinum. Then it's turned into the red molecule and diffuses out. Now what happens inside there is that this is a little platinum thing, it stretches that bond, it weakens it, so that when the hydrogen comes along, it can just just react with that bond, and then it gets released. The platinum never changes. So a catalyst is defined as a substance that can accelerate a chemical reaction, but maintain its own character. It won't change. It just uses electrons and energy. Now here's an example of catalysis. If you have carbon monoxide and oxygen, if you have to heat it to get it to burn, you'd have to heat it to 1,000 degrees Fahrenheit. That activation energy is because it has to reach certain conditions before they can react. And that activation energy is what keeps nitrogen from converting to nitric acid in the atmosphere. Thermodynamics would say it should end up as nitric acid, but the Lord has provided a huge activation energy for that, so that it does not. Now, if you put a platinum catalyst in there, this activation energy is reduced, and it will oxidize at 100 degrees Fahrenheit. And we have a laboratory reactor. This is an old picture. You can see that computer there. It's pretty old. But we put the catalyst in this the silver tube that you see, and then we feed the pollutants that you would find in your truck exhaust one at the same time. We feed them, mix them together, and put them through the catalyst. And then we have infrared, FTIR, flame Fourier transform infrared spectrometer, all this equipment that's capable of analyzing all those. If you went to an inspection station in some states where they do inspections, they would analyze the exhaust and tell if you're in compliance or not. Now, when you do the test, this is the curve that comes out. And this is the first time you've ever seen this, I'm sure. But if you run this gas through the catalyst, you'll start to convert the material down to fairly low temperature. And it will just climb right up. It looks like it's going right up to 100%. But at some point, all this rattling around occurs, and that limits the rate. So it starts to curve off of there because the molecules now have to go deep into these little channels to get to the platinum. And then eventually it'll get to mass transfer. What that says is they're blowing through there so fast they don't even get a chance to hit the catalyst. And then eventually it will go into homogeneous combustion, but the temperature will be very high. So now the catalyst meets the target. We put it through an aging test, an activity test, and we think we've got something good. Now we have to find a way to use it. And here is an exhaust. This would be the can that contains the catalyst. Flow comes in from this 2-inch pipe. It will spread a little bit, but most part, pressure drop of that catalyst is so low that the exhaust just goes right through. And where the catalyst is not reaching the catalyst, where the exhaust is not reaching the catalyst, represents about 80% of the total catalyst surface that's available. So we tried lots of things. This one, we had sort of different plates with different holes in them. We put that right up next to the exhaust. And that caused it to disperse through the whole catalyst. That was good, but the pressure drop, you have pressure drop on your engine, it's going to reduce the performance. So that one didn't work. But this one did. And that's just a cone that held up there, and the gas goes all around the cone. So it might be a little short in the center, but it's covering the rest of it, of the catalyst. So you got the good use of the catalyst that you have. And if you take one of these mufflers apart that you have on your truck or your car, you'll find a little flow distributor in there. So R&D can do a lot in generating all the design criteria. But so the R&D chemical engineer is the guy who does the catalyst testing and modification. And the design engineer is the guy who designs the can and flow distributor, and they work hand in glove. So that's my presentation. Being a chemical engineer for me has meant a lot. I think like a chemical engineer. A lot of problem solving, planning resources and all that. And I think all engineering degrees are great for going into business. I was really, at age 50, I started my own business. We had a planning program, where you plan your life. And I planned for a year ahead, but never a lifetime ahead. So in this course, I said, I was 40 at the time, and I said, what do I want to do in the future? I want to run my own company. I'd seen a lot of mistakes that were made by management style. I just had the desire to have my own company. And so at age 50, I tried it. And when we would get an order, we'd have to run over to Home Depot and buy pots and pans so we could dip the catalyst in it. And somehow I found a guy who had a factory, and he was making lead products, and he didn't want to make lead products. So his factory had all the equipment that we needed, and we moved it to Knoxville and then to Maryville. And that was like 35 years ago. And last month, we sold the business for $25 million. And I had already been bought out, so I didn't get any of it. When I was 80, I sold my business to my son and another person, and they paid me out of the profits of the company. But now my son, who's rich, says, "What would you like, Dad?" I said, "Well, maybe a yacht." Carol said, "No yacht." So you never come home when you're on the yacht. I used to take church groups out on the yacht. But it was a big houseboat, was it was, like a yacht to me. And I said, "How about a mountain home?" "Okay, I'll get it for you, Dad." I said, "No, let's hold off on that. Snakes and bears and things. I'm not interested in that." So it was a lot of fun, and now I'm starting a new company. I'm going to use some of along the way, you make observations that you say, "Well, that's interesting, I patented it." But we never used it as a product because we had a bigger fish to fry. And now some of those old ideas. If on a diesel truck, They have a special filter, it's about this big around, about this long. Some of the bigger trucks, the filter's like this big. And what it is, if you imagine a stump that's got lots and lots of holes in it. If you plug on this end, you let it, keep it open, on the other end you plug it. And then so you've got a tube that goes down, the only way the gas can go through is to go in and through the walls. And that's what they use for the diesel soot trap. What I've discovered is that you can, if you put a membrane in that, you can filter out viruses and bacteria and all the nasty things. So that's my next business, is going to start out emphasizing filtration for viruses from water. And also these, what they call forever chemicals. I don't know if you've heard about those. The plastics form like these little nodules that are like small, like a colloid, very small particles. And as we drink water, and I'm not using plastic bottles to drink out of anymore, because they shed a little bit of plastic and they form these little balls and they end up in your brain and your kidneys and every other place. So that's the business I've started. I've got a lot of people interested. I got a guy who was a salesman for him. His daughter is a microbiologist. And, I think we got maybe #1 employee. Just need to raise some money. And what happens when you get money late in life is that you think of your kids and your grandkids. You allocate all that, and there's nothing left over. So if I wanted to buy a yacht or something, I would say, oh, it's coming out of the grandkids. Kids and the grandkids, I guess we all get like that. But,
I have a question. The little yellow dots in there,
platinum metal.
if the exhaust improves when it hits the dot,
Yeah, the platinum.
why don't you put more dots in it?
Hmm?
Why don't you put more dots in it?
Bucks.
Oh.
You know, when I started Catalyst Research, gold was $32 an ounce, palladium was $40 an ounce, platinum was $80 an ounce. Within the last year, platinum went to $5,000 an ounce.
So that's the issue.
Yeah.
So how does the catalyst that you built for the gas lines compare to one that's on a car?
Well, first of all, we've learned how to make the platinum more effective, smaller diameter, use less of it. But it probably has about the same concentration of the platinum. But the catalyst in your truck is probably this big around. The platinum on the pipeline is like this big.
But is it the same concept, just bigger?
Mm-hmm. And you know, some of the stuff's really dirty, like it has sulfur in it and all that, so we put filters on to try to get some of that out. It's been a lot of fun. I mean, we struggled. When Carol and I got married 33 years ago, I had $0 and she had $30,000. We were just thinking, which one of our kids can we live with? It didn't work out. And I have to give God all the credit.